So you've decided upon a research question. You've gone through the process of deciding on exposure, comparator, outcomes, follow-up intervals, populations, inclusion criteria, and so on. Now comes the time to think about, has anyone else attempted to answer your question? If they have, did they do it well? Or were there flaws in the design or the execution that makes you think that it's worth redoing it and redoing it properly? Maybe the study is fine in and of itself, but the findings are interesting and there might not be a lot of studies with the similar research questions, so you want to repeat the study to verify findings. And maybe there are variations of the study that are worth studying further. It could be dropping one of the exclusion criteria, altering the definition of the population slightly, so there's small variations that still could yield very important findings. Has nobody attempted to answer your question? Why is that? Sometimes you actually have a novel idea which would be worth investigating. Sometimes your idea might not be so great, and that's why nobody else has studied it. But don't think like that. Don't be discouraged. Even though nobody's studied something, doesn't mean that it's a bad idea. It could be novel, and maybe it just needs a tweaking or two to fall into line. Get a colleague to think about your question and see if they agree with you that this is a good idea that hasn't been studied before. Have many attempted to answer your question in studies or closely related questions? Is there a systematic review and meta-analysis that tries to combine all the available evidence? If not, is it worth doing one? So before you go ahead with an all-out design of a study, think about these things first. Don't take it for granted that if somebody already has attempted to answer your question, that your question is a dead end. Repeating studies, getting verification of studies is very, very important as well. Think about when you're looking for the through the literature that there are a lot of databases available. There's PubMed, PubMed Central, Embase, Central, CDSR, Web of Science, Scopus, PsycInfo, PsycArticles. The list is long. Learn how to use search techniques and how to search in these databases. Learn how to use the Boolean operators of and or not and how to combine keywords. Look through abstracts and titles, use mesh terms and so on. I cannot emphasize enough what a superpower it is to be able to search in these databases. We live in such a fast-moving global world where there's a lot of information coming out all the time. And I believe that this is one of the core superpowers a human can possess in our day and age, be able to find information and sift through that information quickly. Get a hold of a good librarian. They are extremely valuable and can help you out to learn how to search the databases, find relevant keywords, teach you about how the different databases works, and so on. This is worth investing time in. Okay. You've gone through this, you've decided, I want to do my study. Then we're going to look at 4 different study designs. We're going to look at the randomized controlled trial, systematic review and meta-analysis, observational cohort, and case control. You're not going to become an expert in either of these through just looking through the materials in this website and course. I've been doing randomized trials for the better part of 10 years. I've been in the planning, designing, execution, and analyses of roughly 15 large-scale randomized controlled trials. And I wouldn't say that I know how to run a trial. Nobody knows how to run one. Each study is unique, and there's going to be unique aspects to consider. You learn new things every single time you do a new study, and you should be learning new things every month that is going to enhance your ability to run studies. So nobody's fully learned. And for sure, the information here isn't going to make you a complete scientist in either of these, an expert in either of these. And so what I want to show you is when one study design might be appropriate over another, and some of the core things that you should think about. If you decide that you want to do a case control study or you want to do a meta-analysis, then get a hold of somebody who has done it before and who you feel could teach you more about them. Get a hold of books and papers who have used the methods before and read up. One of the most dangerous things in the world is somebody who's taken 4 credits of statistics and then yields that as a superpower, just cutting through everything with their 4 credits. Nobody's fully learned. But we're going to look at these 4 and we're going to get you a running start. For the randomized control trial, we ask, well, is it possible or ethical to allocate treatment? Is that a possibility? Because then a randomized control trial might be an option. In that case, we randomly allocate each individual to either treatment or a comparator. We follow up all the individuals over time, and we contrast the 2 groups. These contrasts are then considered causal, and that's licensed by the randomization component. So we're going to talk about randomized control trials in a minute. If there are 2 or more studies which answers closely related questions, a systematic review and meta-analysis might be useful. Can they be meaningfully synthesized, these studies? That enhances the probability that your systematic review and meta-analysis will be useful. If there are quantitative estimates of effects available, then a meta-analysis could also be done. And combining studies may help to reduce uncertainty from single studies. And it marginalizes away differences across studies if you have enough of these, enough studies to include. We're going to talk a little bit about this, but I must say, just going through the process of doing a systematic review and meta-analysis enhances your ability to think about the academic process and the process in which we run studies, and you learn so much about other studies and how to, in a meaningful way and in a critical way, appraise studies. If randomization of treatment or comparator isn't possible, or if it's unethical, then an observational cohort might be an option. If individual preference is important, or if you're measuring compliancy, then observational cohort studies are also useful. Here we observe participants with varying levels of an exposure, for instance, health behavior, and we follow them up over a period of time to examine 1 or more outcomes. Confounding makes causal claims require more work, and so you should use a causal model. I just want to point something out here, that this is just a language thing, and for me it sounds right in my head to think about treatment when we talk about randomized controlled trials and exposures when we talk about observational studies. Really, you could talk about treatment here as well and exposure here as well. It sounds right in my head, but we're not actually making a difference between the 2. The 4th type of study is case control. And it's useful if we think that a full cohort study is not within budget or takes too long time. There might be a pressing public health concern that we need to deal with, and a case control study would be quicker and cheaper to run. We investigate a sample of the participants of the cohort, either a real cohort or an imaginary one. It limits us in the available statistical quantities that we can use, a little bit based on the design, so we'll look at that. And as with an observational cohort, there's confounding, which makes causal claims require more work, and we need to use a causal model. So we're going to have a look at these 4.